All right, so now we're going to be looking at the Hamming code. Now, the Hamming code is a special code because it has a special feature that it can detect errors in information that's been received. So, when we send in information, we send the data across usually a wire, and we send it um, in terms of voltages. So, when you look at this information here, this data that's sent, you can see there's zeros and ones in binary, but these binary numbers, the zeros and ones, represent voltages in reality. So it's not a whole bunch of zeros and ones going across a line, it's actually a bunch of voltages. Okay, so a 1 could represent 5 volts and a 0 could represent 0 volts. And when this gets sent along a wire, there is many factors that could interfere with those voltages. You could have a high powered three-phase line next to it that's creating a large magnetic field that could interfere with these signals that's going through our communications wire. Another thing is the sun. So sometimes there's these huge explosions on the sun called solar flares, and they cause huge amounts of electromagnetic interference. And those travel towards Earth, and they can interfere with the communications that's happening over these wires. And one of these zeros could potentially become a one, and one of these ones could become a zero, and then the information that's received is incorrect, and that's a problem, because then you'll get the incorrect message. So how we deal with that is we use error detecting codes like the Hamming code, and we're going to see that this code can actually detect where the error is, and then we can know what it should be when we receive the information. So this information, so you read the question and it says here, detect and correct the error in the following received Hamming code word. And that's the key word there, is received. When it says received, you know that it has the parity bits in it already. Okay, so this top line here, you just have to memorize this so it doesn't change. So P1, P2, D for data, P3, data, 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 P4, data, data, and then you can add a couple more D's if you need to. Yeah, then you number these positions from 1 to 10, and then you fill in this received information into those positions. So you can just see I've just filled it in as it is into those positions. Then these parity P1 checks, parity P2 checks, and there's parity P3 checks and parity P4 checks. Those positions you have to memorize so they never change. Okay? And then what you do is you fill in this line here these positions that they want you to indicate what information is in those positions. So let's do that. So it says here position 1, position 3, 5, 7, 9, and 11. And we don't have anything in position 11 in this information. So position 1, we're going to put down a 0. Position 3, we're going to put down a 1. So we just transfer whatever's in position 3. Then we go to position 5 and we transfer that information, which is a 0. Position 7 is another 0. Position 9 is another 0. And we have nothing in position 11. So now what you do is you look at that and you say, okay, how many ones is here? All right, and we see there's only one 1. Okay, and to make that an even parity number, what would you do? You would add another 1 to it. Okay, so there's only 1 there, which is an odd number of ones. So therefore, you can add a 1 there and it'll give you an even number of ones. There's another way you can look at it as well, is you can say how many ones are there, and you can say it's an odd number of ones, so you can write 1 for odd. Okay, let's do the next one. So now they want you to do P2 parity checks, which is 2, 3, 6, 7, 10, and 11. All right, and let's transfer that data now. So we got in position 2 we got a 0. In position 3 we got a 1. In position 6 we got a 1. In position 7 we have a 0. In position 10 we have a 1. Okay, and again there's 3 1s, which is a uneven number of 1s. So there, to make it even, we can just put a 1 there. Okay, then we can do the P3 checks, which is 4, 5, 6, 7. So in position 4 we can transfer down a 0. In position 5 we can transfer down a 0. In position 6 we transfer down a 1. In position 7 we transfer down a 0. Alright, and again we have an uneven number of 1s, so the parity to be added to make it even would be a 1, because now we have 2 1s in this row. Okay, then P4, 8, 9, 10, and 11. So in position 8 we have a 1. In position 10 we have a 1. All right, so now we see that we have an even number of ones here, so we don't have to add a parity. We don't have to add a 1 for parity, so we put a 0 there. All right. So again, there's 2 ways you can look at it. You can say the exam papers usually have it like this. You count how many 1s there are, and to make it even you would put a 1. So there's only 1 there, so 2 would be even, so you put an extra 1 in that row. Here we have 1, 2, 3, so it's odd, so we add an extra 1 to make it 4, which is even. Here we only have 1 1, so we add an extra 1 to make it 2 1s. And here we have 2 1s, which is even, so we put a 0 there. Okay, then we do is I've got this arrow drawn up the side here, so you can see it's 0, 1, 1, 1, and I'm going to write it here in the answer here. The error is in position 0, 1, 1, 1, and we know that is the binary number for 7 in decimal. Okay, and then we just have to look at the original data, and we go to position 7, and it's a 0. So that is where the error is. Okay, so let me highlight that. The error is in position 7, and then I'll highlight the 0. And we know that if it's a 0, then it should have been a 1. All right, and the corrected word now is 0, 0. We move that up a bit. 0, 0, 1, 0, 0, 1, 1, 1, 0, 1. Right, so that's the corrected information. So that's the information that should have been received, but it wasn't. So the data or the bit in position 7 was altered by some sort of external interference, and now we've detected where that error is, in which position, and we have corrected it to what it should have been. Okay, so there's the corrected word.